Welcome back everyone. Today in this lecture we are gonna hands-on with computer vision MediaPipe with specifically real-time hands tracking project. Before we start, what do you think is common in all these pictures? Think for a while and guess what is common in all. Yes, your guess is absolutely correct. Module MediaPipe is common in all these images. Every YouTube video we watch in processed with machine learning models using MediaPipe. And Google has not hired thousands of employees to watch every video people upload because thousands of people are not enough to look after and check the videos. So the amount of data Google gets daily is not easy for humans to check. So machine learning models are developed to make our life easier, and tasks that are hard for us to complete, that is machine learning and deep learning models helps us to do in less amount of time. On other hand, we can save money by not hiring employees. Yes, Google has machine learning and deep learning models to see if the videos match their policies and the content is not having copyright issues. Basically, MediaPipe is a framework for computer vision and deep learning that builds perception pipelines. For now, you just need to know perception pipelines are some sort of audio, video or time series data that cache the process in pipelining zones. And Google has been using MediaPipe for so long, and mainly Google uses it two tasks. First one is dataset perception for machine learning training and machine learning interface pipelines. So basically in dataset perception for machine learning training, we can say pose estimation means finding a person's or on an object's key points. Basically a person's key point are elbow, knee, wrist and etc. So pipe this library can be used for training the machine learning model to learn the key points and further use the knowledge for a specific task, and this actually can be useful for action recognition. And second one is machine learning interference pipelines means live data. So machine learning interference is the process of running live data points. For example, we all have used Snapchat, Instagram filters and may have recorded videos. This is what machine learning interference means. And there are a number of artificial intelligence problems that can be done by MediaPipe. Here are some are mentioned, like object tracking, box tracking, face mesh, hair segmentation, live hand tracking and many more. So we are gonna start with real-time hand tracking project. So here I have developed the live hand tracking project using MediaPipe. So hand tracking uses two modules on the back end. One is palm detection, that is basically work on complete image and crops the image for hands to just work on the palm. And second one is from the cropped images, the landmark module finds 21 different landmarks on the hand, like wrist, thumb, CMC and etc. So first step is installation of modules. For this specific task we require three modules, CV2, MediaPipe and time. So we can install all the modules, or we can say libraries of Python, by installing PyForest in the Jupyter notebook. Then once the modules are installed and the next time when this command is run, so the output will be shown like this, like requirement already satisfied and something like this. And if MediaPipe is still not installed and does not work, install it separately, because MediaPipe is the newest module. Maybe it is not yet included in the PyForest. As I thought to work directly on Kaggle notebook, but found out that MediaPipe was not working. I installed it and worked on Jupyter notebook. So Jupyter notebook do not require internet. It is a plus point. This is how MediaPipe is installed in Jupyter notebook, like you can see in this figure. Our next step is importing modules. You have to just import the CV2, MediaPipe and time. So now in this code I have created a camera object just to check if the camera is working properly or not. So here is the output for the checking the camera. After this, created a hand object from hand class so that BGR images is converted to RGB, as hands object only uses except RGB. So in this code we are creating an object from class hands, and hands objects has 4 default parameters. Static image mode means it tracks and detects the false, means sometimes it detects and sometimes it tracks, and second parameter is maximum number of hands, and third is minimum detection confidence, and fourth is minimum tracking confidence. After this, basically before extracting hand further details, make sure there is something in the object means result. Do this simple step, means use a print statement and print the object result to see what it holds. It just shows the MediaPipe solution based solutions, nothing else, even if the hands is shown. Then update the print statement by putting the multi-hand landmarks function and see if the camera is detecting hands or not. Now as I have updated the print statement, the information I am getting is none because no hand is shown. Let's see what information is extracted when hand or hands are shown. You see when the hand is detected by the camera, it gives some values. Then in this code, the drawing object is created with mpdraw function. Further, the if statement says that if the landmarks are detected, the for loop will run and draw the point whenever landmarks is detected. Interesting, right? See in these images that are shown, the landmarks are detected and points are drawn. After this, connections are drawn by using a hand object with mpHand.handConnections function, and you can easily see the drawing connections between landmarks. After this, for FPS, 2 variables are declared. One is P time and second is C time, previous and current time. P means previous and C means current time. Then just in case if any specific point is needed to be tracked for any purpose, as we know there are 21 landmarks in hand, means 0 to 20 as shown in previous slide. So the landmark information gives the x, y and z coordinates with ID which are listed in the corrected order. So we can use x and y coordinates to find the location of landmarks on hand. Then here I have checked the height, width and channels, means H, W, C of the image, and in the previous code I have got the decimal values, and now I wanted the exact integer, therefore I have converted the circle values, means Cx and Cy, to integers. So for drawing I have created a drawing object that is called mpdraw function, and further I have declared an if condition for point 0 because I wanted a filled circuit at the landmark 0. And for fingertips, the landmarks are like 4, 8, 12, 16 and 20, and see the code. This is how we can use these landmarks for different tasks. Here I am ending the video. Also, it is not the end of the study, there is still a lot to explore. Also, you can find this complete repository. For source code, you can simply go to bit.ly to exec lkiw.